So I'm here today with Dr. Clint Shock. So Dr. Shock, what was your specialization and what position did you hold?
The last position that I held was the director of the Oregon State University Malheur Experiment Station. And so the specialty that I've always had has been to try to refocus my attention on what needed to be solved, rather than stay comfortable with what I already knew or what I always did.
Okay. So what has horticulture meant to your life and career?
When I was 12, I decided that I was going to do plant research, and that I was going to go to Eastern Africa, and I was going to have the experimental plots, and I was going to find answers to problems and make agriculture more productive and serve people. I never did. I've never been to Eastern Africa, but I had this dream of using plants and plant science. That was my idea.
Well, so what was the most rewarding part of your career in horticulture?
Well, what I've done is, in each situation I've been in, or each area, I've tried to solve problems. So I've always grown crops and done plant experiments, but I've tried to make the focus of my life and attention on the things that needed to be solved in the community that were related to ag. So when we were on the frontier in Brazil in the late 60s, the key thing that was needed was to have a free market economy, which didn't exist. In the mid-70s, there wasn't any information in Brazil on how to restore degraded vegetation, degraded sites. And so we did the first revegetation research in both the Amazon and the Serra do Mar. And when we're then in Ontario, Oregon, addressed the potato dark end problem, the problem of groundwater contamination, the problem of overzealous regulation on bacterial contamination of crops, the food safety acts of Congress, and we showed that we could put vast amounts of filth in the water, and bacteria would not survive on the onions. We'd have nice, healthy onions, and we were able to determine that most of the bacterial problems on a number of different crops was actually coming from imported fruit and vegetables rather than U.S. produce. So each time I may be working with onions or potatoes or many other crops, but then around the sides looking at ways to solve fundamental problems that needed to be solved, be the environmental or economic.
Okay. So how long have you been an ASHS member, and how did society influence your career?
Well, I was trying to publish a number of articles through other journals, and I found that one of the fundamental things in life is to be fair. That's what my mother would always teach. And so that led me to a couple of principles. One of the principles is, well, you set up your experiments, you look at your trials, but then you don't interpret the results based on your hypotheses or your original ideas. You interpret the data based on how it came out. And so you're not trying to just build up a big data set that favors what you already thought. And when I started working on potato darkings, I ended up with lots of results that contradicted the powers that be in the potato world in terms of what caused sugar ends, dark ends. We found out that it didn't happen the way it was described. The mechanisms of physiology weren't right in the literature. And I found it very difficult to publish results in some of the more stayed-in-the-world journals. So I gravitated to try HortScience and the journals of the society. So 29 years ago, I became a member, and then I became a real heavy reviewer for HortScience. And it was over 20 years that I did a lot of work for the journals in horticulture, in the American Society of Horticultural Science, and served on the editorial board finally of HortScience once I formed an editorial board. But the heavy lifting was more between 95 and 2015. During that 20-year period, I found that the journal was very fair, very helpful, and so I poured a lot of effort into helping make the journals work.
So, what advice can you offer students or young professionals that want to get into horticulture?
Well, I think that there are lots of opportunities. There's more opportunities than there are problems that are solved. And so I think it's worth looking at things, and within, say you have a job in a particular area, don't look at just that job or the minimum things. Think about the whole society and how the society works and how things are working for growers, and take on important tasks, take risks, do things that are extraordinary, that you're not expected to do. Don't be afraid, if you have some competence, don't be afraid of doing something outside of what you already need to do. You can find allies and friends, and if you don't find them within your own university, you can find them in another university or the other side of the country, or in a private company. And so you can imagine bigger ideas and bigger dreams. And the review journals, help the society that you're part of. Get involved in thinking through other problems and other articles. And if you need to read 4 or 5 articles in the field to do an adequate job of reviewing an article, do it. There's articles that I've taken over half a week to review. And the only time I do that is if there's an article that is really fundamentally important, and it's been, say we have an article written by a Chinese scientist, and their English is very poor. So a number of articles that I have reviewed and written out, except for publication with changes, I've written hundreds of changes because I've come to the decision, this result is really important. This work is really important. And if this young professional gets this published, then their attempt to do this really important work will be satisfied. So instead of just throwing it back on them and say that English isn't adequate, provide everything that they need, so you can just say, this is acceptable with revision, and give them all the revisions. I know it's a rare thing to do, but when I was reviewing articles, I did that every couple of months. I'd take something that I thought was really a great result, really a good article, and completely just throw myself into it. So that, so one of the things that happened is that one time I did 2 articles for the same author. And so that author went after the journal and found out who the heck it was that did this. And so it turns out I have, a very good friend. It wasn't intended to be that way, but it was just a type of decision. So it's a matter of taking a risk, going beyond the minimum of what's needed, giving an effort for your society, take professional risks, do things that really ought to be done. The other thing that I think is really important for a new scientist in any field is to follow the data. I come up with all sorts of ideas. Some of them are cockamamie. Some of them are really good. And they don't fit necessarily the hypothesis, or they don't fit what's already published. And so rather than just fixing up the data, live with it. And maybe living with it means that there's something more there than what other people have seen. Sometimes the results of carefully done work contradict what other people have already published. And if you have work and results that contradict things, well, you have to go back and repeat it and make sure that you did it right. But if there's a contradiction, maybe the mechanism behind how some phenomena happened was misinterpreted in the past. And so people thought that they knew why starch turned to sugar in a potato, and it didn't happen that way at all. It didn't happen with that timing. The stress timing that caused the problem was different. The path of physiological changes was different. The mechanism was different. It turned out that everything was different about potato darkings than what was published. So that's why I was running into so much trouble getting any of that published in the American Society of Agronomy or Potato Journal, because it all contradicted what was accepted as fact. And what's accepted as fact today is different than what was accepted as fact in the 80s. And that was a very significant problem for the potato industry at the time. So I think it's really important to be honest with yourself, follow the data. If the data doesn't jive, it doesn't fit in, it doesn't, were all the methods right? Did we make a mistake? But then repeat things and do things carefully and find competent cooperators. And things may be a more simplistic idea is what originally got published, and that may not be the way things actually work. And so following the data, even when it's inconvenient, has been a really positive thing in my life. It was positive in the revegetation in Brazil, revegetation work in Brazil. I was blessed there to have a technician who would tell me honestly what actually happened in, in comparison to what was been planned to happen.
Yeah.
So why does it look different? Well, it didn't actually happen the way it was supposed to happen. Well, then that puts you in a really strong position because you can interpret things from a point of view of reality. So having someone that you work with that's honest and will not varnish the facts. That's it's a wonderful thing. I think that when you think about the future, there's a lot of people that feel down on the present, and they feel like, gee, things just aren't really working, and the world isn't that way at all. The way the world is that there's only been a couple of generations where we have a fairly long expectation of life. Here I am, 78 years old. I don't hardly hurt anywhere. That's because medicine has been able to fix things or give me an artificial shoulder where I didn't have one. There's just so many miracles. We didn't have computers that were efficient and effective. The cars that we have now are really efficient in fuel, and they're going to become more efficient. The cars that we had when I graduated from high school and college, 7 miles per gallon, clunkers, and today they're efficient, and it's a thing of beauty. There's so many things that are really nice. A lot of the medicine that we have is based on the indigenous people around the world and the plants that they consume and the things that they found were helpful. Well, they could only explore those plants that they could consume. If something was toxic, they couldn't really test it or check and see whether there was any secondary metabolites in that were beneficial for humans. There's got to be 100,000 species, plus their endophytes, that exist out there that have descended for a couple 100 million years. All those species have had to deal with virus, they've had to deal with fungus, they've had to deal with bacteria. They and their predecessors and their ancestry that came to them have had to deal with an onslaught of all sorts of difficult things. Well, today we don't have to look at only the secondary metabolites of those things that have given us aspirin and given us Taxol for cancer and all. But we can look at more and more species and come to a more profound understanding of flavonoids and coumarins and all sorts of stuff that we ought to be able to have even better health. And so those secondary metabolites are in ornamental plants and weeds and trees in the forest and other things. And only now are we going to be able to start to look at them. And all of these plants have had to deal with onslaught of pests and diseases and whatever for essentially an infinity of time, much longer than humans have been around the earth. So just that area is got so much exciting potential. And there's other areas as well. But there's just many, many opportunities. I feel
your excitement. I think it's a bright future.
It's fascinating. Right now, I'm working on a plant that some herbalist thought it was something else, and she was having magnificent results with it, and she thought it was something else. And since I was growing that something else, I asked her if she could show it to me because it sounded like extraordinary. Well, she was generous and she showed me the plant, and it wasn't what she thought it was. And nobody knows what's in it. and it seems to work on several maladies. And so there's a treasure trove of biochemistry in this plant. It's all happened because of a mistake. So
Sometimes that's the best
there's a lot.
way to find something.
There's a lot of neat things. So yeah. Anyway, there's ways to imagine things differently. If there's a production system that's relatively inefficient and uses a lot of manpower or hand labor, it's possible to re-envision that particular crop and think, well, what would the structure of this have to be so that it could be harvested efficiently? When would it have to mature so it could be mechanized? Those kind of questions can be asked today about hemp because it's being harvested late, it's being harvested manually, but the structure of the plant doesn't have to be the way it is. The structure can be different. We changed the structure of soybeans, we changed the structure of wheat, we changed the structure of corn, we changed where the leaves are on corn plants so that the sun comes down through the plant more efficiently. So there's no reason why things that are done inefficiently can't be changed. Anyway, that's the way I look at the world.
Well, I appreciate you being with us today.
Yeah.
Thank you so much.
Thank you for all your time. I know we've exceeded the speed limit here.